Press the bell icon on the YouTube app and never miss any update from Tech Primers. Decorator design patterns are another common usage inside the design patterns in Java. These decorator design patterns are otherwise called as wrappers. Why are they called wrappers? Because they add behavior to an existing object without affecting the other objects. It uses the single responsibility principle. So every implementation or a concrete class has its own responsible feature implementation. It also dynamically computes the behavior of a particular implementation or a interface. It is a combination of inheritance and composition. If you don't want to create common subclasses like how we did in the other design patterns, then you can go for the decorator design patterns. So these are an alternative to create subclasses. There are constructors which are required because you need to have instances created from the hierarchy. So let's go ahead and see how we can create the decorator design pattern. I'll create a new package for the decorator. We are going to create an interface called phone interface. And what we are going to do with the phone interface is we are going to build a phone. So similar to the other examples which we saw about the phone, we are going to do the similar stuff. However, we are going to see how we can use the decorator design pattern here. So we have an interface called phone, and what the phone does is we are going to build a phone. First, we are going to create an implementation of the phone, which we can call it as a basic phone. So we are not going to add any functionality to this particular phone. So we are going to create a plain phone, and we are going to call it a basic phone. And we are going to add the basic phone as let's say screen, right? The basic phone has a screen, so we're just going to print screen when somebody calls the build method. Now in order to decorate a phone, we need to create an abstract implementation. For that, we are going to create the concept of the smartphone. So smartphones might have different stuff, right? So we are not going to implement the build here, and I'm going to make this as an abstract class. So what we're going to provide in this particular smartphone is when somebody is implementing a smartphone, they should be providing a phone to it. So either it can be a basic phone or it can be some other type of phone. So let's create a constructor here, and we need to provide the phone interface to it. And let's create this object here. And when somebody calls the build method in the smartphone, we will call the build method from the phone. That's it. So this is an abstract implementation of a phone, which is a smartphone. However, we are not telling what type of smartphone it is. So it could be an Android phone or it could be an iOS phone, right? Or maybe a Windows phone. So we have a phone interface initially, and we built a basic phone out of it. The basic phone had just the screen. We did not have anything. Maybe we can add screen and battery, processor, right? That's it. It had just the basic stuff. However, we are in creating a decorator. So this smartphone is nothing but a decorator. So this is going to add some features to the smartphone. So we can create implementations of this smartphone to have features built to that. So let's say we are going to create a iPhone, right? I'll say Apple phone just for the naming convention. Apple phone. I'll create one more called Android phone. So these are two decorator implementations. So these are concrete classes of the decorator. Let's go to the and Apple phone, right? So if you notice here, we have the constructor pushed in directly to the abstract class. We need to implement now the build method, right? Because it's not done. So we are doing a super.build, which is fine. However, we need to also create our own additional feature to this particular smartphone, right? We need to add something to the smartphone. So we will add an OS, and that OS is going to be an iOS. Let's say iOS version 1.0. So this is what decorator does. Decorator can add new functionality or the behavior to the existing implementation. So for example, smartphone is an implementation of a phone, and we are adding different OSs to that particular smartphone, and the smartphone is nothing but a decorator. However, basic phone, if you saw, it was just a basic phone implemented from the phone. It doesn't have any decorators, it has just basic features. So let's go to Android phone and do the same. I'll just say add OS, similar to what we did there. I'll add a Android OS version, let's say 6.0. Now, how do we use this particular implementation? Let's see that. Decorator example. So how do we use it? So we need a phone. We need to create a phone. And what type of phone it is? We are going to create a Android phone, correct? We are going to create an Android phone. Let me name it as Android phone so that we can create an iPhone later. We are going to create an Android phone. However, in order to create an Android phone, you need to provide a basic type of phone. So what this will do is this will create a basic phone and give it to the Android phone. And when I do Android phone dot build, this is going to build something. Same way if I do this for iPhone, right? Or the Apple phone. Let's say Apple phone equal to new Android phone of new basic phone. I just need to provide the existing basic phone, and I use this Apple phone as a decorator. So this Apple phone is a decorator implementation, and I just use that to build my phone. So phone is just the basic phone which I'm providing, and Apple phone is the decorator here. So I'll just build the project. Let's see what does it give. So we need to create an iOS, a phone with the basic features with the iOS, right? I think I need to print this guy. I did a build, but I need to print because that build is returning in a string, right? Yeah, if you notice here, we have a screen, battery, processor, and the Android phone. However, let's say we want to have a different functionality added to an Android phone, right? For example, I'll create a let me create a go to the phone. I'll create a OnePlus phone, right? I'm going to create a OnePlus phone. This is another decorator. I'll show you how you can use the decorators across here. So I'm going to okay, I'm not going to use it from the phone. I'll use it from the smartphone because it's a smartphone, right? Let me go to smartphone. I wanted a smartphone which is nothing but OnePlus phone. The additional in addition to the Android phone, right? The smartphone will have some additional features, isn't it? So I need to have a phone which can provide both. So let's take an example of a Nokia phone. So here, this could be directly an Android phone. However, let's say I'll rename this as a Nokia phone. That way we know we can provide a Windows phone or we can provide an Android phone. So I'll just show you that how we can use decorators. So I'll just say Windows phone. So I'll just provide a public string build. Plus add OS, and this is going to add the Windows phone version, let's say 1.0, and I'm going to create one more implementation called the Nokia phone. So Nokia phone, let's assume that Nokia phone can support either Android or Windows, right? So I'm going to create exactly similar type of behavior. I'm going to say build. Here I'll just say super.build plus. I need to add some functionality to the Nokia phone, right? I'll just add a branding. I'll just add the branding saying Nokia phone or Microsoft phone. Now when I use this particular phone in the implementation, right, how will I use the Nokia phone? So I'll need to create a new Nokia phone, right? I'll just say new Nokia phone. However, I can make it an Android phone or a Windows phone. So for simplicity, first I'll do a Windows phone. When I create a Windows phone, again I need to provide another type of phone, right? Which is nothing but the basic phone. Because in order to create a Windows phone, you need a basic prototype of the phone, right? That is what we have done here. So we are creating a new basic phone, we are providing that to a Windows phone, and the same we are providing it to a Nokia phone. So and this is nothing but a Nokia Windows phone. And in order to print that, we'll just say Nokia Windows phone dot build. So this will build a Nokia Windows phone. Same way, if we want to build a Nokia Android phone, we are going to use a different decorator, right? We used already a decorator. So here we will just change it as Android phone. That's it, and we'll just change this name as Nokia Android phone. And if I just build this, if you see how the decorator pattern works, this is how it works. So you can provide different patterns. See this, right? You have the screen battery processor with the Windows phone version 1.0, and along with that it says the branding as Microsoft phone. And for the Android Nokia phone, it says Android OS version 6.0 along with the Microsoft phone branding. So this is how you can create decorator patterns. So what we did here is we created a phone. Phone is just at the higher level. This is an interface, and basic phone is an implementation of the phone which builds a phone with basic features like screen, battery, and processor. We have created a decorator called smartphone. This is the decorator which is going to use the phone here to decorate it. So we are not having anything else, we just have a phone, and the smartphone will directly use the constructor argument for creating composition. So we are going to implement the smartphone with Android phone, Apple phone, and Windows phone. These are different concrete implementations. So you can directly create an Android phone or an Apple phone out of those implementations of the decorators. Let's say we want to create a Nokia phone. The Nokia phone can be of similar implementation. If you notice, we just add the branding to it. So these are just nothing but the behaviors. So we add a behavior to a smartphone, and it is using single responsibility principle because it is doing only the branding. So Nokia phone is just doing the branding, and if you notice, the Android phone or the Apple phone is just adding the OS. So these are the single responsibility principles. And finally, we create a Nokia Windows phone or a Nokia Android phone based on the decorators which we have created here. So this is how you can use the decorator pattern in the code when you are using it. So let's see some of the disadvantages of the decorator design pattern. So what are the disadvantages of it? So every time you create a new functionality, you have to create a new class for every feature. That is the disadvantage. Since we have new classes, the complexity increases because of the number of objects which are more. Since there are more number of objects, the client might feel it is more complex. If you notice this difference between the Nokia Windows phone and the Apple phone, there are too many objects creation here. So the client might feel that it is too complex for me to provide different objects to it. So it is more complex for the clients. The general usage of the uh, decorator design pattern in the Java API is in the IO streams. You create a file, you create a file output stream or input stream, and then you provide a file to it, and then you provide a data stream, and then you use that to parse the file and stuff like that. So that is a typical example of a decorator design pattern. So I'll upload this particular code to the GitHub repository as always. You can get it from there for any reference. That's it for this particular video. I hope you like the video. If you like the video, go ahead and like it. If you haven't subscribed to the channel, go ahead and subscribe to it. Meet you again in the next video. Thank you very much.